And as you will all be aware, this call is being recorded. So if they've missed the first bit of the meeting, they can catch up later through the GRA website where the recording will be hosted. Well, thanks everyone for joining today. Good morning. Predominantly, assume most of you are from Europe or European time zones, but if not, welcome. Good afternoon, maybe. Good evening. I'm Brian Lindsay. I had the absolute pleasure of project managing the MiLCA project and working with a number of colleagues to get to this point where we're pleased to be able to launch the MiLCA Protocol to help us move the dairy sector and other sectors forward in terms of their mitigation activities. This project actually started in mid-2022, so a 3-year duration, and they say if things were easy, they would have been done by now. And I think we had many good discussions through the development of the MiLCA Protocol before we could get to this point to make sure we got it right for the industry. And even through the public consultation we ran on the protocol, the draft protocol, we used that to find out how the industry would react and respond to certain decisions that we had to make, certain critical decisions on how we can practically apply a protocol. This is a new area of science. We recognize this as a stepping stone in the development process, but it was an important part of the process that we had to get started because technologies were out there for mitigation. They were being applied, but they weren't being reported. And that's crazy if we've got technologies that work that we cannot incorporate into our footprinting activities as part of the reporting. And really, this is really about industry collaboration. Industry came together, they recognized a common issue for a sectoral challenge, and they worked together in achieving this outcome of MiLCA. But we're also pleased to have benefited from the relationship with the Global Research Alliance and making sure our respective work programs were aligned, adding value to both programs. And of course, for hosting the MiLCA Protocol on their website and for this webinar today. So we couldn't have done it without you, GRA. Thank you. And we appreciate your guidance and efforts throughout the process. So today, we have 2 excellent speakers for you. First, we'll start off with Jeroen Dijkman, who's head of Nestlé Institute of Agricultural Sciences, based in Vevey, Switzerland. And we have Erin Simmons, who's the senior research scientist at New South Wales DPI, Australia, Department of Primary Industries, that is, for those of you who aren't in the locality. So we're going to start off with Jeroen, who's going to set the scene a bit for us. Jeroen, I'm conscious that the Diamond League Athletics is happening in Lausanne at the moment. I hope we haven't taken you away from your competitive training program to be with us today, but we certainly appreciate your time. Jeroen, over to you.
Yeah, it's been tough, Brian, but here I am. Just found a little space in my training program. So good morning to all. Good afternoon, good evening. I'd just like to give you a little bit of a background. I think you all know Nestlé's commitments to achieving net zero by 2050, and we're still fully committed to that. And as a result of that commitment, the company not only talks about it, but we also invest about 1.7 billion per year in actually efforts to achieve that. And that includes our work on transforming agricultural supply chains from which we source, looking at our operational emissions, product innovation, different offsetting projects that we're involved in, but also and foremost, ensuring that we are transparent and held accountable for what we report. Now, if you then think about Nestlé's product portfolio, dairy, as many of you will know, is where Nestlé started. It's part of our DNA, but it remains also a very central part of our products and business strategy. About 40% of all Nestlé products have got some form of dairy in it. And it is really essential to the focus and the future of the company and the essential role that we think we play in nourishing people around the world and responsible practices. Because of that large amount of dairy that is part of our portfolio, of course, it's also the single largest contributor to the carbon footprint of the company. And so a large part of the investments that we make in moving to net zero are also directed towards dairy. And in that, it is both about making sure good practices within our supply chains, but we also have a large amount of research going on to look at new types of solutions. And whilst we're doing all that, we use obviously the best of science and try to use robust sort of measurement, reporting, and verification protocols to really track accurately and to report accurately our reduction in greenhouse gas emissions. Now, throughout this all, obviously, you find that there's lots of products, technology on the markets that claim, but if you actually check them, they don't actually deliver what it says on the tin or on this pack, or and so this is obviously leads them to misreporting, commitments that are not being met, and obviously we felt, as with our partners in the industry, that it would be good to move with the science, make sure that we actually have a common way, a transparent way of actually including, measuring, and reporting, based on reliable data, the progress that we're making and that different technologies make towards it. So the protocol really that Aaron will be presenting later on is really trying to make a dent in that, to come to a science-based agreed protocol that allows us to comprehensively and reliably report on the impact that different technologies have on the carbon footprint of, in this case, our dairy industry and our dairy sourcing. I will allow Aaron to present what we have come up with. I think it's important also to highlight that this is not the definitive protocol as such. We will continue to adjust it as science evolves and science improves. But we've made some decisions that I think will allow us to do that. But also in the meantime, come up with verifiable emission reductions that we can report on, and that will definitely support Nestlé in its further journey towards net zero. So I hope you'll enjoy the presentation that Aaron will make, and we're happy to receive any questions after that. And Aaron will answer most of them, and I will support them.
Thanks so much, Jeroen, and great introduction there. And very much appreciate the point you make about working collaboratively as an industry to try and come up with that common approach. And I think that common approach is really important because at the moment our industry is suffering from reporting fatigue. So trying to find a single way that we can all adopt is really important. And that certainly came out through the development process. So now we're going to hand over to Aaron. Aaron led the science team. And just before Aaron starts, I think it's important to understand that, this wasn't a group of dairy organizations who sat in a dark and smoke-filled room who came up with a protocol. We went through a process of identifying a science team, a multidisciplinary science team that could help us achieve this outcome. So it was very important that we had the science right, but we had to be able to practically apply it. And we needed that breadth of experience to help us through this journey. And Aaron pulled together a team of Australian scientists, and Aaron will share that, to help us on this journey. So it was a collaborative approach with the science and industry working together to achieve this goal. So Aaron, I'm hoping that Tanya can get your presentation loaded for you, and we can crack on.
Okay,
here we go.
Coming up. I'll get started while Tanya's doing that. So yeah, the brief that I guess the brief that we fielded when we looked at pardon me, developing the MiLCA protocol, you can go on to the next slide, Tanya, please, was really one about setting up a protocol that would build trust with consumers and shareholders, and to build that trust through credibility, essentially, so that when somebody saw on the label that an emissions reduction had occurred, that they would trust that and that they would take that at face value. And that's what we need when we're looking at greenhouse gas emissions reductions in the agricultural sector. As was mentioned, there's a lot of products out there that claim to have amazing benefits, but there's not a lot of evidence that underpins the greenhouse gas emissions reductions that occur when you use some of those products. And so when we developed the protocol, we looked at it from a very high level, and we considered international guidance around greenhouse gas accounting and greenhouse gas emissions reductions to really identify what the key themes were. And when we did that, we decided that the best way to actually achieve those goals of credibility and trust was to integrate 4 principles into the protocol. Now, the 4 principles are there. So I've only got another 4 slides after this one, so I won't talk for very long. But really, those 4 principles were the common themes that we identified. Pardon me. So if you want to go on to the next slide, please, Tanya. So the first thing thing that we built into the protocol was that we needed to make sure that any technologies that were used or that were implemented in dairy systems were safe. And so safe relates to everything. So it relates to human safety, so human health, as well as the environment more broadly. So we don't necessarily want to see a technology implemented that does a great job at reducing greenhouse gas emissions, but then the trade-off associated with that is an increase in impact somewhere else. So a lot of countries have a regulatory framework that requires technologies that are going to be implemented in agricultural systems to be approved. So in Australia, for example, we have the Australian Pesticides and Veterinary Medicines Authority. And if you want to use a farm chemical, essentially, whether it's for animal health or for weed control or pests, that kind of thing, then you need to get a regulatory approval through that authority. So when somebody develops a report for or using the MiLCA protocol for a particular technology, they have to actually attach evidence that regulatory approval for that particular technology has been granted for the jurisdiction in which the technology is going to be implemented. So that means it's essentially legal to use. So in Australia, for example, you just can't go and get a chemical and spray it over your paddocks because unless it actually has approval through the regulatory body. When we looked at the other environmental impacts, we decided that it was actually quite important to make sure that not necessarily the trade-offs on other environmental indicators impacts was quantified, but that there was some recognition that trade-offs occur and that a process had been followed through just to make sure that there weren't any really major negative impacts occurring elsewhere once a technology was implemented. So what we included in the protocol to achieve that was that people had to provide an LCA, a life cycle assessment of the technology, and it had to be compliant to the international standards, the 14044, ISO 14044, which is the LCA standards. And then there's a range of environmental indicators. We weren't specific about those environmental indicators because for some technologies, there would be relevant environmental indicators, but they're not going to be relevant for other environmental indicators. So there's a suggested range of environmental indicators that people need to consider, but really the environmental indicators that are reported need to be justified. And then the final one was the impacts to the farming system. No farmer wants to do anything that is going to have a negative impact on the system. That's their job, that's their livelihood. And so, pardon me, needs to be demonstrated that there's no negative impacts on animal health, but also product quality. And so that's where human health comes into it. So it needs to be demonstrated that there's no, when it comes to dairy, that there's no milk taint, and if people are selling coal cows into the meat market, that there's the product doesn't leave residues in the meat, that kind of thing. So particularly for countries like Australia that have that export a lot of the commodities that they produce, you know, that's one of the key criteria. We can lose market access by having residues in products that we ship overseas. But, you know, in general, it was more about making sure that consumers trusted what was being done, that they had trust in the implementation of the technology, and they knew when they picked up a dairy product that they could consume that and there wouldn't be any adverse effects. And that has to be demonstrated. There needs to be written evidence that the process has been followed to make sure that that would not occur when somebody does a report for the protocol. Okay, next slide, please, Tanya. Okay, so this is probably one of the critical ones in my mind, and it goes back to what's been mentioned a couple of times already, and that there's evidence to support that using a technology will actually reduce greenhouse gas emissions. And so we based this principle about having adequate scientific evidence to provide confidence in the greenhouse gas emissions reduction capacity of the technology. So the key hurdle, I guess, that needs to be jumped is that you need to have what we phrase demonstrated repeatable reductions, and that can occur in one of three ways. So the first one is one peer-reviewed meta-analysis in a scientific journal. Another way is to have a minimum of 3 peer-reviewed scientific studies published in a scientific journal, or a methodology from a carbon crediting scheme that is certified under an international carbon crediting scheme body. So that essentially provides confidence. Now, when we talk about scientific journals, there are journals out there. There's predatory scientific journals. There's journals of different qualities. And so we actually specify the quality that the journal needs to achieve on an international register that ranks journals. So it can't be poor quality research that's published in a low ranking journal, because that doesn't meet the criteria of robust evidence. So it's not, that kind of evidence isn't going to provide confidence. And it's very easy it would have been, if we hadn't have put that limitation on, it would have been relatively easy to game the protocol by doing a quick study, publishing it and saying, here we go, we've got the body of evidence. So we really made sure that the evidence required to demonstrate that a technology is effective was very robust. Okay, next slide, please, Tanya. So the third principle is that claims are conservative, and the purpose of having a conservative claim is to make sure that the greenhouse gas emissions reductions that are claimed when a technology is implemented isn't overestimated. The principle of conservativeness is included in pretty much every international carbon crediting scheme that has any reputation. It's also included in the Article 6.4 of the Paris Agreement. So it's very much a universal strategy to ensure that the greenhouse gas emissions that are claimed, or emissions reductions that are claimed, don't overestimate what has actually occurred. The way that we went about making sure that claims are conservative, and I won't bore people too much with statistics here, but the approach that we used was an approach that actually features in a number of carbon credit methodologies. And so what it does, it adjusts the amount or the emissions reduction for the probability of exceedance. So if we look at the probability of exceedance of 0.5, which is the average or the mean, what that means is that because that average is an estimate of what the true mean is, where the true mean pardon me, actually lies, there's a 50% chance that it's greater than the mean that you've calculated, and there's a 50% chance that it's less than that. So when you look at IPCC guidance and how they phrase uncertainty in the IPCC reports, having a p-value of 0.5 or using the mean equates to saying that it's as likely as not that the greenhouse gas emission reduction had occurred. So that doesn't really provide confidence. That's not a responsible approach to take if you want to make a greenhouse gas emissions reduction claim. So what we did, we used a probability of exceedance of 0.7. And so that shifts the number a little bit. And when you go to the IPCC guidance and how they phrase that, that changes the language to that the emissions reduction was likely to have occurred. And so just by having those statements and aligning the p-value to those statements in the IPC generates trust in the consumer and the shareholders. It generates credibility. The other thing that, or one of the other purposes behind using that approach was that the better the data that's used in an experiment to demonstrate that a technology is effective, the lower the uncertainty. And the lower the uncertainty that you have means that the shift that you get when you move from a probability of exceedance of 0.5 to 0 or 0.7 gets smaller. So a poorly designed and implemented experiment that has a large uncertainty, so we don't actually know really where the mean lies, would have a bigger discount applied to the greenhouse gas emissions reduction than a really well-designed experiment that has a low level of uncertainty around that estimated mean. So by doing that, it actually incentivizes researchers to make sure, and technology developers, make sure that the research that is done and then published to justify the effectiveness of a technology is really high quality. So it was very much put there as an incentive. Okay, next one, please, Tanya. And the final principle was that data needs to be appropriate. Now, when I talk about data, I'm talking about farm data. So if we look at how a greenhouse gas emissions intensity or a carbon footprint of an entire farm is calculated, we need farm data. And that can be anything from the live weight of a dairy cow to the number of cows in the herd to pardon me, the number of calves that are born, so the calving rate, the amount of milk produced per head per annum. That kind of data needs to be high quality, because having high quality data actually provides confidence. If we knew that a carbon footprint was generated in Australia using data from a farm in New Zealand, then nobody's really going to trust the number that's generated, because it's completely irrelevant. And so what we did, we actually picked up an existing data quality framework that's used in the life cycle assessment world, and we modified that for the protocol. Now, we included 4 data quality categories, that gave us a bit of an idea about how good that the quality of that data was. And so those categories were reliability, which just means it gives an indication, was it directly measured? Was it inferred through, was it inferred through some kind of equation or a model, where clearly if you're directly measuring a variable and getting a number, it's a higher quality than something that is, calculated using a model or an equation, that kind of thing. There was also completeness, which just means was the data taken from the system that was being assessed, or was it actually taken from a similar system somewhere else in the same region? And clearly, if you've got data from the system that you're doing the carbon footprint from, then that's always going to be higher quality data, because it's more relevant. But sometimes it can be impractical, or it can just be very costly to get that data. So we had to make sure that there was flexibility in the approach to allow that to happen. Also, temporal correlation, which just means that was the data from the year that you're doing the footprint for. So if the data is for the year that you're doing the footprint for, that's very high quality data. As soon as it starts getting old, well, it becomes less relevant. But sometimes, it might not be possible to get all the data. And so we had to be flexible about that as well. and then there was just an overarching category of geographical correlation. So was the data coming from a particular farm? Was it taken at a regional scale? So it's more about picking up data from statistical organizations and that kind of thing when it was used in a particular calculation. So what we did was we actually integrated the data quality into the calculation of the discount that is generated when you adjust it for uncertainty. But one of the key things that we did was that if the highest quality data was used in any calculations when you were to calculate a greenhouse gas emissions reduction, then there was no additional discount applied. But as the quality of the data became lower, then it actually applied an additional discount on top of the discount for uncertainty. And again, we did this to incentivize farmers to get the highest quality possible data, because then that means, or sorry, not just the farmers, it could be the dairy processor, to get the highest quality data possible, because then they can make a greater claim. And I guess it's well known, particularly in Australia. I think we're a little bit behind some other areas of the world when it comes to collecting farm data. And we really saw that there needed to be a mechanism to make farmers and processors aware of the need for high quality data. And that is the end of my presentation. So that's about 20 minutes. Hopefully that's a high enough level overview that people get a good understanding of what's contained in the protocol, and also why we did what we did, you know, some of the justifications for including what we included in the protocol.
Thank you so much, Aaron, and appreciate you keeping that at a level that even a numpty like me can understand. Thank you. It's really important. Certainly through the whole process, I certainly learned so much more about statistics than I ever thought I would ever in life. But well done to you. That's why we need experts like you and Jerome guiding us through the process. Just to let everyone know, we are now going to move into a question and answer session. So if you can put your questions in the Q&A session, tab on the bottom of the screen, and maybe we'll try and get through as many of those possible. We've got about 29 minutes to go, or maybe 30 minutes to go for questions. So please put them in there and we'll try and get through as many of them as we can. And I think maybe if I can just start off with a question to you, Jerome, because you've invested a lot of time, your time, and also finance into helping get this protocol developed. There was a challenge there. And maybe it comes back into one of the questions I've got in the chat already about how many tools in the toolbox do we need? The question is, what global warming degrees in Celsius from rumen methane are we going to mitigate by using technologies? And I'll just flip that a bit and say, do we need the new technologies to achieve our ambitious goals as an industry? And you as an organization have made big commitments and you need many tools in the box. So what's next for you now? How do you see this all being put together for Nestle?
Yeah, I'm reading the question as well. So, look, I think before we get into the discussion, I think it's clear that we need to mitigate both our carbon dioxide, nitrous oxide, and methane emissions. Now, obviously, the relative impact and the timeline under which that impact occurs is going to be different. At the moment, when it comes to reducing either total methane or methane intensity, there is a few tools in the toolbox, and I think many of the participants will know that applying good agricultural practices in quite a number of dairy production systems can significantly reduce those emissions related to the product. But it's not enough, and definitely not enough for to reach the ambition that Nestle has declared. What we're trying to do with this protocol is to make sure that any technology that has that potential, that we have a protocol to ensure that the claims that are being made or that we make with respect to its mitigation potential are not only transparent, and verifiable, but also reliable. And as I've said before, obviously, the protocol will help us in doing that. We're looking forward, of course, to all the people online to start using it and to give us their experiences. And as science progresses, we will make updates. At the moment, there's a question: what will actually the number be? Well, that depends on the technologies that will come online. We all know that there's large developments going on. I think we also know that the only really, if you wish, certified product that is out there at the moment is BOVAR. So let's see. I think there's many organizations that have large pipelines with new products, new technologies coming online, and we highly encourage them to look at the protocol, use the protocol to make sure that whatever claims are being made are verifiable, and also increase that confidence in the industry that what we are reporting and that our efforts are not based on greenwashing, but on real science.
Yeah, great. And just leading on from that, maybe both of you, we'll start with you, Jerome, maybe. Who do we see as the main users of MiLCA? You've just said yourself, we're looking for those online to be using it. Who do we see as the main users of this protocol?
I think what we're looking at, of course, is the industry and in its broadest form to start using it. I think its use per se is going to be probably at the levels of the Danones and the Fronteras and the Nestlés. But I think what is important is that it provides scientific guidance to the industry and science as a whole on what is required and what international processes and currently available sciences tell us. I think it also, and Aaron has mentioned that already, it rewards and encourages, good science. It rewards and encourages, repeat observation. And I think all of those are essential in ensuring that what we report is based on robust science. And again, I think it really provides an incentive to pursue that.
Yeah, thanks. Aaron, if I can come to you now, there's a few questions in the Q&A about the peer-reviewed studies, and I know we had a lot of discussions about, there's a bit of angst about how do we set the boundary somewhere. We had to do something. And, there's about a question here about, showing, is there any guidance on how to handle studies with contrary results? And I know we had discussion about, do you just cherry pick the science? And there's another question about, do we just assume because they're in a high quality journal, it is good quality science? Can you just talk us through a bit about how we arrived at the point we did? Because I know we had lots of conversations about that.
So I guess the thing that I didn't explain, and I remember now that I didn't explain it, was how you actually use that science or those scientific publications in the protocol. So really you could look at it and say, okay, there's a published paper, and it's a meta-analysis of, emissions reductions from the implementation of 3NOP, and to estimate those emissions reductions, you need 4 variables that are part of the animal's diet. Now, you then pick up that equation, because that's where that uncertainty comes from. It's the uncertainty around that equation. And you pick that up and you apply that to your dairy with data that you collect around those 4 particular variables that are in their diet. So, could be fat, crude protein, pardon me, that kind of thing. And I will say that, this approach isn't perfect, but we had to find a balance. I had to be workable, and we had to try and make sure that it wasn't easy to be gamed. But if we made it too difficult, then it would be unworkable. So it really was trying to find the right balance, and hopefully we have found the right balance, or at least close to the right balance. But what you need to do when you choose a particular article or a particular publication, you actually need to justify its relevance to how you're applying that equation. So that can be everything from, how long a product's effective for. So if a study, the longest that a study shows that a technology is effective for before, a biological system reverts back to what it was is 3 months, you can't claim a reduction for longer than 3 months. So also with the system, if you've got research that shows that a particular feed additive will reduce enteric methane in barn-raised animals, well, you can't just go and use that in a pasture-based system, because you don't have the evidence to support that particular technology will have the effect that it will. So it really starts narrowing down the studies that you have that that demonstrate that the technology does have the efficacy that you're claiming and that you're going to be using, pardon me, to calculate an emissions reduction. I guess the final thing that we did put in place is that a report needs to be generated. And so that report introduces transparency. So if a particular company wants to make a claim and they have a report that shows how they've implemented the protocol, and they have gone and used completely irrelevant science to do it, then people can pick up on that. So again, by having that transparency, that generates confidence, it generates trust in the consumer. So there's nothing to be hidden. So I think in the end, the onus is actually falls onto the user of the protocol to do it properly, because if they don't, then it allows an accusation of greenwashing to be made, and the whole purpose behind generating this protocol was to reduce the risks of greenwashing claims being made when something was done. So I think I suspect, or I hope, it will only be used in in a genuine way, in the intent that it was actually developed. So hopefully that addresses that.
Sorry, just while I've got you there, I mean, you mentioned it several times through your presentation about how you went and looked at what's already out there, existing knowledge. How the MiLCA process is really about a lot of existing knowledge. We just brought it together in a new protocol. There's not a lot of new stuff developed. So a lot of this is already out there and being practiced already. Would you like to just put a comment on that?
Well, yeah, so we did look at, and I've helped the Australian federal government develop carbon credit methodologies for different practices in agricultural systems. So I already had experience in developing policy around robust claims for greenhouse gas emissions reductions, mainly in sequestration. And so I was transferring some of that thinking to a reduction that occurs because you implement a technology. I guess the unique thing about the protocol was that we had to think of a protocol that filled the gap of how do you integrate a technology into a carbon footprinting process or a life cycle assessment process, pardon me, so that it generates a result that is trusted and that it's credible. And there is actually nothing that does that. Or there was nothing that did that. That's why this protocol was developed. And so the unique thing about it was that it actually drew on multiple components. It wasn't just about carbon sequestration in soil or trees. We needed to understand, and the multidisciplinary team, we needed to understand what was happening when it came to regulatory approvals. We needed experience and knowledge on life cycle assessment. We needed statistical knowledge so that we could make sure that what we were doing was robust when we actually did the discounting for uncertainty, that kind of thing. So it really was a case of pulling a whole heap of existing knowledge together, modifying some of it, so it had to be fit for purpose, and also doing it in a way that provided flexibility so that we had something that was usable, while also finding that right balance between flexibility, usability, while also generating trust and confidence in the claims that were that were made through the use of the protocol.
Jerome, just coming to you now, and we've always said about MiLCA, yes, it's about providing confidence in you as a commercial and other commercial organisations being able to report and not be challenged or reduce the risk of being challenged. But there's another point here is about, we've always said about MiLCA, it will guide the development of new technologies in terms of what they need to do, building on the GRA work, but also about the amount of science that needs to sit behind it and things like that, about bringing it to market. But there's a question here about, have we put any thought to the cost that bureaucracy would add to the development of new products? But it's a real balancing act, isn't it? Because if you're going to use something as a commercial organization, you need to have the confidence it works and that you can actually, as you said, verifiably report, isn't it?
Clearly, the good science comes at a cost. Unfortunately, bad science also comes at a cost, and there's quite a lot of that going on as well. So I understand the question. I do believe that, if we look at the landscape out there and the amount of money that is being spent on the development of new types of technologies, my assessment is that there is enough money out there to do good science, but unfortunately also enough money around to do bad science, and so I think we need to be clear about what is required, and let me go back to some of our own experiences. Part of the work that we do is actually taking some of the commercial projects that are out there and testing and validating them in our own research farms. And in most instances, we find, as I mentioned in my introduction, that those products don't live up to the claims they make. Yet, they are being used in dairy systems. Farmers pay good money for those products. Claims are being made, and so that really is the trade-off. We want to move to a system where we reward good science, but also make it clear to the users of those technologies that when they introduce that into their production systems, it really delivers what it says on the package. And I think one of the other things that is happening, and which is good to see, there's obviously increasing number of consortia that are looking at this problem. Agricultural emissions, livestock emissions are obviously part of the societal challenges that we need to address. And I think this is also increasingly leading to consortia being formed, money being pulled together to be able to invest in opportunities, but also to be able to invest in the type of science that will give the robust evidence for the industry to move ahead. And definitely Nestlé, and also I know from our colleagues in Danone and Fonterra, are investing significant money into supporting that, and also into investing in our own science to make that happen.
So, if I can comment, Brian.
Yeah.
There needs to be something to limit particularly farmers investing in technologies that don't work. But there's an example in Australia where it's recognised that good quality evidence is required if people want to be able to make a claim. But it's also required if technology is going to be integrated into national greenhouse gas accounts at a country level. And at the moment in Australia, there's a fertiliser technology that will reduce greenhouse gas emissions associated with putting nitrogenous fertilizers on soils. And there's actually really good data for these products, but there is no data for it in irrigated cotton, which means that the cotton sector, even though we know it reduces greenhouse gas emissions, they haven't been quantified, and we haven't developed emissions factors or emissions factors curves if you use these products in irrigated cotton. And so I'm on a project that is funded by the federal government, by the cotton sector, and by the actual fertilizer companies, where we have where we've got chambers installed in fields where cotton's going to be sown this year, and it's a 4-year program, and we are going to start collecting that data, because without it, the cotton sector won't be, and this is one of the big levers that the Australian cotton sector can pull to reduce its greenhouse gas emissions. Without that data, that technology has absolutely no purpose, because there's no evidence to make a claim, and they're making that investment. You know, there's millions of dollars going into a program through the entire cotton growing region of, or all cotton growing regions of Australia, to collect in-field measurements so that we can do a meta-analysis and publish it and have that evidence. And I had a conversation with somebody from another state today, where they were saying that there was a person selling a particular technology that was very similar. So I pulled out a recent paper that was published for Australian conditions with a range of these technologies, and sent it to him and said, look at table 3. There is no value in table 3 that tells you what the emissions reduction for dryland cereal production is if you use this technology. You cannot do it. You cannot advocate for that people to use that product, because we have no evidence on the quantum of abatement that it can provide. So there's no value there for a producer to make that investment.
And Aaron, while you're on that train of thought, there's some questions in the Q&A about level data quality, secondary, primary data, and is farm data really that much better? And what about who's going to be the validator? Who's the auditor picking up the farm data, and how do we know that's going to be right? What's the thinking around that? I mean, you've been to Europe, you've seen many dairy companies will be sending auditors onto farms to collect data and things like that. But how do we get the balance right? And do we need to start working with our farmers to collect different types of data than maybe what we have traditionally, to benefit from being able to make claims in this space?
So when we developed the protocol, we didn't actually see that the verification or validation of data was the responsibility of the protocol. We wanted the protocol to be agnostic, because there are different greenhouse gas accounting frameworks, there's different target setting frameworks, and they all have different requirements on what you need to do so that you can report your greenhouse gas emissions, or report against a target that you've set. And that is where we felt that the validation verification process should sit with those frameworks. We weren't trying to override or be prescriptive about what needs to be done. So we left that to actually sit within those frameworks. So it could be applied to whichever approach was being used to do the greenhouse gas accounts or report against a target. I've forgotten the second thing. I've written different types here, and I can't remember what the second part of the question was. Sorry, Brian, or the second question.
It was really about who validates, how do we know that farm data is going to be accurate as well, or as accurate as possible? And do we need to start collecting data, different data, to benefit from?
Yeah. So yeah, there's definitely a challenge about from the Australian perspective, getting farmers to collect data and to collect better data. But then there is also what we would normally collect to do a greenhouse gas calculation. There may be variables that need to be collected that doesn't form part of the normal data collection process. So to do a greenhouse gas account in Australia at the moment, it doesn't matter what the crude protein content of dairy cattle is, the intake for dairy cattle is. But when you implement a technology that reduces enteric methane, that may suddenly become important. And so there is definitely a need to, to be aware that there's potentially different variables that need to be collected in future that aren't currently collected, and look at ways of, and we're doing this for the grains and the cotton sector, but looking at the ways of doing automated collection and automated verification so that it makes it easier for farmers to report data through the supply chain, because we don't want it to be an imposition. It's something that will need to happen. But if we can set up systems that automate it and do an automated verification process, then again, so it reduces the imposition on the farmer, but it also generates trust in the end user or the consumer and the shareholder.
Okay. And a good point of clarification here. I mean, in terms of different technologies being applied at the same time. So what's our thinking around that? Are they cumulative, or how do we manage that process if there's a number of different technologies being applied? How does a MiLCA model manage that?
You need evidence. So if evidence, people get sick of me saying evidence. If you have a technology that is going to reduce, or you want to make a claim that two technologies are reducing the same greenhouse gas emission source, so let's say enteric methane, and so you have two supplements and you're going to feed animals two supplements, and you want to make a claim about the emissions reduction associated with doing that, you need to have evidence in scientific studies that feeds animals those two supplements at the same time, and then you can make a claim. You can't pick up one for one supplement, one for another one, and go, I assume they're additive. You can't make assumptions. You need evidence that they are additive, because they might not be. We don't know unless we've actually got studies to confirm that there's an additive effect and the magnitude of that additive effect. Then you can't make a claim. If you have a fertilizer technology and you have a technology that reduces enteric methane, well, they can be applied separately because it's not that same greenhouse gas emission source.
Yeah, brilliant. And just a point here, and that came up about the application of MiLCA, and we recognise that there'll be a range of users out there. And the question's more about, it's a comment really about, how will different users interpret MiLCA and apply it? And I think that's part of the journey we're on, isn't it? I mean, we want people to use it. We also want them to give us feedback, and we've set up an information about this into the GRA website. There's an opportunity for members or users to give us feedback, because, as I said right at the beginning, this is a starting point for how we move forward from here. Before MiLCA, we were limited as to what we could do. Now we have a step forward where we can report technology use with confidence. Yes, it will evolve as science and knowledge evolves. And I think that's important that we do. There may be different interpretations of that, and that's something we will monitor going forward as an industry. And I think it's important that we join the dots and try and have these common approaches. Yeah. Now, I'm conscious of the time. Aaron and Jeroen, is there any points you'd like to just finish up with in terms of finishing the call about how you'd like to see things move forward with MiLCA now that it's released and we want people to use it? Maybe I'll start with you, Jeroen, about how you'd like to, see MiLCA be seen out there by the industry.
Yeah, thanks, Brian. Let me first thank people online for dialing in. And as I've mentioned before, I think we see it very much as a starting point. Unfortunately, when it comes to the science we're dealing with, it's not an exact science. It will never be, and so progress will be made. Things will need to evolve. But I think that will only happen if the protocol is actively used for different purposes, probably by different users. And so what I think we would like to see as the group that put this in place is really the experiences, but also the improvements that can be made. And we are well aware that this is not perfect. Aaron has said it a couple of times, but we also believe that is a step forward what is out there, and I think it's part of a genuine attempt to improve the robustness of our mitigation reporting. And I think that is not only important from an industry point of view, but I think it's also something that we owe to the many stakeholders in the industry to make sure that when investments are made, they actually get what is promised back from those investments. And I think unless we are able to do that, the future of the industry will continue to be challenged, and I think making sure that we move towards a more sustainable footing for dairy, but agriculture in general. It will require these types of initiatives, these types of protocols, and this type of robustness and credibility as we move forward towards the various commitments that have been made, but also just in general to make agriculture more sustainable overall. So thanks again
Jeroen.
to all online. Looking forward to your continued comments and questions.
And thank you, Jeroen. And you just raised a really important point there about agriculture in general. Although dairy has been used as the model for MiLCA, the principles of MiLCA can apply across a range of different agricultural commodities. So you're absolutely right to raise that. And Aaron, you've already mentioned how it might be being applied in other sectors. But Aaron, final word to you. Look, I am conscious that there's a few comments that have come into the chat. We'll take note of those. Sorry, we haven't been able to get to them today. Aaron, just final word to the science team.
Yeah, I'd just like to acknowledge that wasn't just me. There was a team of people behind it, researchers, statistician, the companies that were all part of the project. So it was very much a joint effort. I am looking forward to improvements because it isn't perfect and there will be ways that we can improve them. But the only way we're going to identify them is through the implementation of it. That's how you find out where there's some holes in anything. And yeah, I'm adapting it for the cotton and grain sector. So I intend to use the principles that are in there and apply that. So make sure that the Australian cotton and grain sector have a solid foundation on which we can make any claims that occur from the implementation of technologies to reduce the greenhouse gas emissions from those sectors. And thank you for everybody for listening today.
Brilliant. Well, thanks so much to both you, Aaron, and you, Jeroen, for taking time out of your busy flight schedule, Aaron, and training program, Jeroen, for Lausanne. But thanks, everyone, for joining us today. And please, if you want to see the recording, it will be on the GRA website. But also do interact with us. I mean, we're not going to go and change this next week, but we do want to connect with our industry as this protocol does get applied, and we will learn together and evolve this stuff together so it's right in terms of blending the science and the commercial activity. So thanks to you all today for joining the call. We really appreciate you taking the time, and we look forward to hearing from you through the GRA. Appreciate everything. Cheers.